All right, folks, welcome to the Friday, August 1st PS enablement session. Max is going to be taking us over GitLab reference architecture sizer.
Thank you,
For
Glenn.
as a reminder, please keep it safe. No customer names, no financial information, etc. Otherwise, take it away, Max. Thanks.
Thank you. Um, you can see my screen, right?
Yep. Gotcha.
Okay. Okay. So welcome, and today I'm gonna share with you a small utility or tool that I created to basically have a different approach on how we size reference architectures for our customers. So, as a PSC or a TA, right? So I think you guys have been in this situation where the customer asks, okay, which architecture should we use? And we end up doing sometimes manual calculation, making educated guesses, and spending hours analyzing the environment. This reference architecture sizer tool automates the entire process, and it provides data-driven recommendation that follows GitLab's official decision tree. So let's first talk about like the agenda. We start discussing the most common challenges we face in the field when uh, sizing GitLab deployments. Uh, I'll demonstrate the specific problems these tools solve and problems that I'm sure many of the TAs already encountered. Then we deep dive into the tool's capabilities and see how it integrates with existing processes like GitLab SOS, which is the main process that I'm integrating this tool with. We'll see a live demo, and finally we discuss how to integrate this into customer engagements and professional services workflow. So feel free to ask any question. You can also interrupt me. I don't have any problems with that. So now let's talk about the challenge of right sizing GitLab. Um, so first of all, let's be honest, right? So I guess many of you like have been, in a sizing discussion where the customer says, okay, we have let's say 500 developers, and you're trying to figure out if that means if it's a 2K architecture or a 5K architecture. So there are two basic problems with that. Like over provisioning is a real problem. Okay, so customer complains about costs, and it makes GitLab looking expensive compared to competitors. On the provisioning is also worse. Performance issues lead to customer dissatisfaction and it impacts deals for sure. The decision tree in our documentation is a comprehensive, but it's comprehensive, but it's also complex at the same time. It considers user count, RPS, high availability requirements, um, large repositories, and I think some Kubernetes experience. Usually, a manual analysis is going to take 2 to 4 hours per customer. From what I saw, the benchmarks and stuff like that, and the results can be significantly different between different TAs, right? Different, like the way they analyze is going to be different. So this inconsistency in recommendations can hurt our credibility and customer confidence, obviously. So as a TA or as a PSE, you know that wrong sizing decisions early in the sales process can basically impact the entire customer relationship. So um now this page has like our validated tested reference architectures that the engineering team maintains. Each architecture is just not like it's just not like theoretical, it's actually tested weekly with like real workloads using GPT. And the APS values that you see here are based on actual customer data, right? So including CI/CD workloads, so not just manual user activity, which is usually what we tend to take as a reference point. Um, so many customers don't understand that user alone is not enough. So a company can have like 1,000 HVCI users and might need a 5K architecture. That's the thing. So these architectures are designed to be elastic, so customers can actually start with one and scale up to It can scale up or down. So if it's sized properly, it can scale up or it can scale down if it's not sized properly. So this is where our tool becomes kind of valuable, because it actually analyzes like usage patterns, not just estimates. So you can show customers data-driven recommendations based on their, action environments, and it significantly increases like trust, and it makes sure you can close the deal at some point. Now let's introduce the sizer tool. Um, this tool represents a some kind of advancement in how we approach customer sizing in general. Integrates with GitLab SOS, which many of you already use for support cases. So we can also use that for sizing recommendations. The tool doesn't just look at user count; it also analyzes, like as I said, request patterns, system performance, and usage characteristics. And most importantly, it follows our official documentation, like our official reference architecture, decision tree logic, or whatever. Think of this as like having a GitLab expert, who we can trust into like any customer environment, and can, and provide some kind of recommendation of what could be the right architecture. So for TAs in general, this tool will help qualify opportunities better. So you can identify if customers needs actually professional services, or if they are a good fit for a particular architecture tier. So I think that's the main purpose of the tool. So the tool also provides specific actionable recommendations with links to our documentation. So we're gonna see that in the demo later. There are some specific links when you have to go for a specific architecture or whatever. Um, Now let's talk about key features and capabilities. Um, First of all, the tool does like data collection. So the tool integrates with GitLab SOS, which is basically gathering your infrastructure logs and stuff like that. So how your GitLab instance is behaving in general. For APIs calculation, the tool is using two different approaches. So there's one where we actually analyze, like we do an analysis of the logs, like the GitLab logs when they're available. But when they're not available, we use some kind of fallback approach with like a network traffic estimation. And this is also crucial for accuracy because many customers have like bursty workflows or workloads, sorry, that don't show up in simple user count. So this is basically where this is really important. Um, the tool also uses Rails to run some script for repository analysis. So because I remember the last time I was running it, it was taking so much time because I was using an API. And Scott gently granted me like a way to run like discover manual like large repositories with the Rail command. I actually integrated as part of the script, and it's actually run I would say differently. But there's an interactive mode where you can actually specify that specific thing, and I'm gonna show that later. System pressure analysis also helps identify if the current system is already under stress because, as I said, if you just go with RPS, you're not gonna see all these important metrics that are actually usually hidden in like the specific data that the GitLab SOS tool can actually provide to us. And all of this follows GitLab's official methodology. So using recommendation, the, the documentation where we have like the decision tree when we say, okay, we're gonna use HA or we're gonna use like disaster recovery and stuff like that. So now, let's talk about how the tool works. This is the workflow you will follow with customers. So the first step is actually collecting data. This usually involves running SOS in customers' environments to collect some data from their instance. Step two is actually load analysis. This is usually where the tool's intelligence really shines, right? So it's like it can calculate actual RPS from logs or estimate from system metrics. And the step three is actually requirements assessment. So the tool asks for the right questions about HA, Kubernetes, and disaster recovery result needs. So it's like this is like in a interactive mode. So if you activate the interactive mode, it's gonna ask you some follow-up questions just to make sure you're doing the right sizing. Step four is actually decision tree processing. This is where consistency across TAs and PSCs becomes crucial because the tool applies the same logic every single time. Uh, this is reducing, um, the rate of errors in general. And step five is actually like recommendations, right? You get the specific architecture recommendation with documentation links. Um, so the beauty of the process is like it's largely automated, so you don't have to go manually find those files and try to understand like what is actually involved in right sizing. Uh, and for customer meetings, you can run this through like this process live, showing transparency and how recommendations are actually generated. Okay. Um, Now let's go for a demo. Uh, let me. I'm gonna share it this way. Oh, sorry. I'm gonna take my terminal here. So I was running. I actually fed my instance with some seed data using GPT. And I was stress testing at some point, so I was trying to get some requests going on the cluster. So I did this pre-work because it was taking so much time. So it is gonna save so much time during the demonstration because the tool is gonna run like pretty fine. So um as a requirement, as a prerequisite, I basically run already the SOS tool. So if you see, for example, is this files folder that has like all like the recent SOS data that actually basically run with the tool. And the tool is basically gonna pass this archive and basically get up like all these folders because this has like many folders that have like all this information I'm talking about. And the tool is gonna provide some recommendations based on that. So I'm just gonna run the tool right now to see how it works. It is trying to analyze the environment right now. So it's not under a pretty huge load right now. So you can see, okay, at some point it was actually able to find the number of users, the total RPS. So it was calculating API-based RPS, web RPS, and um, there's no git pull or git push action because I'm not doing anything on the cluster right now. You can also see the RPS calculation method. It was doing the log analysis, as I said. If the logs are not available, it's going to use um, some kind of APIs to basically fetch everything. And then you have like it's a single instance right now, so it is giving you your current environment metrics, and then based on the way it calculated IPS or the way it did like the analysis, it is gonna give you a specific recommendation. So it says it's gonna be like a standalone architecture with automated backup strategy. It's gonna be cost effective approach for smaller environments. So as I said, I don't have any large repository, but there's a way to actually detect large repositories as part of the script. So there's an interactive mode. I'm gonna launch the interactive mode just right now. Uh, okay, in the interactive mode, okay, I don't have any large repositories, so I'm just gonna not gonna respond to this one. Um, so you're gonna see, for example, for if you need high availability or zero downtime upgrades, you can also specify this here. If you want GitLab to be if the GitLab is down, it's going to impact your workflow. You can say, okay, is it going to impact your workflow, whatever. You can say yes. Do you have experience with Kubernetes and resilience? I would say no, even though it's not true. Do you have cross-regional distribution or disaster recovery? No. And do you expect substantial additional workloads, for example, EVCI during periods where the cluster is going to be on the stress and stuff like that. So I can say yes. And then it's gonna give us like a primary recommendation. So this is based on the calculation. It says, okay, you still need like a 1K architecture because it was able to evaluate that you don't have like a high RPS load in your environment. So the deployment type of cluster has to be like reduce high availability, and it's gonna give you some kind of like documentation, as I said. So this is basically where you're gonna follow the instructions, and still gonna give you current environment metrics and specific recommendations. So this, as I said, depending on your needs, but depending on the way you're gonna do the sizing, it's gonna help. The process is pretty fast, as I say, because the cluster is not under like a huge load right now. And I also ran the SOS tool beforehand. I think running the SOS tool in this environment took like 30 minutes. So depending on the environment, it's gonna take more time. So yeah. So this is basically what you're gonna get as a recommendation. And note that this tool has to be like used in addition of like multiple other tools. So we have a delivery kit that we use as part of our comprehensive health check service. And this tool is like the last one that you use. Let's say, for example, you want to give customers specific recommendations and stuff like that. This is where you're going to use this tool. We also need to do some kind of like work on like making sure um, the documentation is actually highlighting this perfectly because I think it's a little bit fuzzy right now. I think we're gonna work with VAMSys to make sure we're gonna do that properly. Okay, um, let's get back to the presentation and talk about benefits and value proposition. So I'm gonna just go back on the slide share. Okay, so usually the tool is gonna basically reduce sizing errors. Let's say, for example, from like 70 to 90% of reduction in sizing errors. So this comes from eliminating like human guesswork and following a consistent methodology, which is going to be improved, by the way. It's still like a work in progress. We can still iterate over this and like add more metrics and make sure it's more accurate with time. Uh, Time savings are actually significant. So if I had to go, it's because like I don't want to go into the deep of like showing what the content of this archive is, but like it's gonna take you at least 2 hours just to make sure you can uh read all these folders and try to understand what is happening on the cluster. Now it takes like 15 to 30 minutes with the SOS tool combined, so everything combined. So, cost optimization through right sizing directly addresses customer objections about like GitLab being expensive. So this is also why, for example, as you saw in the demonstration I was doing, um, even on the stress, like the RPS load was not that huge, so it was still right sizing stuff properly. Um, Performance improvements also lead to a better customer satisfaction and reduce support load, right? So and for professional services, this tool helps with accurate scoping and pricing. Uh, as I said, we have like the comprehensive health check, which is basically going to use this tool. Where you can basically use this tool, it's actually recommended in the delivery kit. And you can compare this to our current manual approach, where it's actually error prone and it's time consuming, it's extremely time consuming. And I would say it's inconsistent depending on your experience, reading these logs or analyzing a specific customer's environment. Generic online calculators don't understand GitLab specific requirements like Gitly, Perfect, or like CI runner loads, but this one is actually going to the deeps of that. And this tool will also like GitLab optimized, right? And it's comprehensive. It gives us like a significant competitive advantage, in my opinion, personally. Now, what about the next steps? Um, Here's how you can integrate this tool to your engagement process for new opportunity. For new opportunity, let's say for example, a customer is not on GitLab yet, we cannot really right size him because he doesn't have any GitLab instance, right? But if, for example, he wants to move, I don't know, to dedicate or something different, We can use this as during the technical discovery to provide accurate sizing at the early stages of the sales process. We can also use the GitLab SOS data collection. It can be provisioned as part of our technical assessment, and customers see this as an added value. It's like running a evaluate on your environment, basically. Use the architecture sizer during the solution design workshops. You can run it live the way I was just doing it, just to make sure the customer sees how transparent it is. And for existing customers, this is perfect for expansion on discussions like on whether they have the right architecture or not. And the tool also integrates beautifully with with Get. And for customers who want automated deployment, this should be also perfect. Um, for complex environments, especially with like large monorepos, it's not like I will always say to engage with PS because this requires some kind of expertise at some point. And the tool also provides like a great starting point, but like complex deployments will always benefit from human expertise, right? So you still need to be competent if you have like a really, really complex environment that you need to basically right size. And yeah, you can just consider this tool as part of your standard technical qualification process. So it's not going to be like a it's going to be like an assistant to make sure you're doing your work properly. So and that's it. Thank you for your attention. If you have any question, you can go ahead and yeah.
Max, is this something you've surfaced with like the essays as well? Because it's one of those things, the earlier a customer is aware or
Yeah.
we know about it, the better.
So when I did the presentation to the CS to the CS group, the goal was to make sure, yeah, it could reach like essays as well. But I didn't have like a full. I didn't see who joined. I saw some essays. I think I also saw the one director of essay, social architecture. So yeah, I think for better reach, this should be also used in the early in early in the sales process for sure. Yeah.
Yeah, because so it's really helpful if the customers agree to a some form of health check where they know we're gonna go in and evaluate the performance and theoretically make changes or at least suggest changes.
Yeah.
I think where we run into problems is when they're not coming in for a health check and they're coming in for something else, and then we realize they really need to like up the reference architecture or right size.
Yeah.
Um, so those are the cases I'm trying to account for, where it should always be surfaced, even if it's not through a PS engagement. We don't want to scope I don't know, like a spinning up geo, and then we go in and realize their primary instance reference architecture is all wrong because that like doubles the effort or something like that. So um, we'll just have to think of ways to make sure that this is being surfaced for anything. I don't know. We'll have to figure out like anything. I don't want to say anything infrastructure related because the customer may also not know. Um,
Exactly. Yeah.
it's like evaluate. They need to run it before they sign any professional service agreement, and that includes like a consulting block or something because we'll sell consulting blocks to just like, oh, let's like advisory, help us spin up Geo, and then it's just it devolves into, oh wait, your reference architecture is a complete mess. You actually what you need is a new deploy entirely. Um, so we just need to be mindful of how we include this and make sure it's regularly included in pre-sales.
Yeah. I agree with you.
But it's really cool.
Yeah.
So walk me through the like the API RPS piece of it again. Are you just using kind of the same metrics? I mean, how are you kind of finding that upper boundary?
So I took as an inspiration, like I think there's a script that has been developed by one engineer. And it's actually, I think it's actually included. I don't know where the repository is again. But I took it as an inspiration to it was in Ruby. That's also the thing. So I actually tried to do it in Python because I'm not really proficient in Ruby and the tool was already developed in Python. But I think for now, it's using the average load. It's not using like the peak load. We need to make sure we can take these metrics only when like the cluster is at its peak, if I can say so. This is also an improvement that I'm working on. I think I have an issue where I need to make sure I'm not just taking average loads when I'm calculating the RPS, but I need to make sure it's only during peak hours. So this also depends on when you're gonna run the GPT, like sorry, not the GPT tool, the SOS tool, because it's gonna collect some data that's gonna be really useful. But like the way I'm analyzing like the logs, um, it is using average loads. It's not using any peak load for now.
Okay.
Does that answer the question?
Yeah, so not necessarily using peak, but running under load,
Hmm.
kind of like in your peak part of the day, if
Yeah.
nothing else. Okay. Okay, cool.
I think you can, sorry, I came a bit late. I think you can though use GitLab SOS to collect logs for a week or so. So maybe
Or
that's
for a week.
something
Okay.
to, yeah, exactly. So maybe that's something that can be like you can use the tool for a longer time span just to make sure that it covers just the peak hours as well.
Okay. I'm gonna take that into consideration because right now I'm just using like days. It's for a specific day. But if I can expand it to like a week, I can analyze like usage patterns and basically, okay, I see what you mean. Yeah. Okay.
Yeah, like it also I think depends on the log rotate, but we
Hmm.
we had like with a case in a customer we recently collected 1 week and then you get this whole um the gzip files which then you need to extract. So there's some manual work to do to be
Hmm.
able to basically get the whole week at the end.
Okay. Okay. Let me just note that.
Something like updated like GitLab SOS has these two options like before date and until date or so. So then it
Mhm.
can be tested.
Okay.
Any other questions, folks? Okay, great. Well, thank you, Max. Appreciate it. Good stuff.
Thank you
Anything that
guys.
helps us do right by the customer, always the best thing. So I will get this recording posted up and will be on the professional service playlist soon and share the Zoom link out to the channels. Otherwise, everyone have a great day. Appreciate it.
All right. Have a good weekend.
Take care, folks.
Thank you guys.
Thanks,
Bye.
Max. Bye-bye.